Welcome to topic 2. In this video, I'm going to be talking about the first part of topic 2, section 7.3 in our textbooks, similar polygons. So topic 2 is all about similar shapes. In this video, I'm going to talk about polygons. In the next video, I'm going to talk about triangles because we have to treat them a little bit differently. So here we go. First thing, similar polygons have the same shape but are usually different sizes. Let's think back to what a polygon is. Remember, poly means many, gon talks about sides. So this is anything that has many sides. And in this case, we're talking about everything except a triangle. So with 4 sides, 5 sides, 6, 7, 8, 9, 10, 11, as many sides as we want, except for triangles. We're going to save triangles for the next video. So similar polygons are going to be polygons that have the same shape but are different sizes. And I can already hear some of you saying, Ms. Zeroni, aren't these just scale diagrams? Yes, they are. So really, we're not adding much more onto what we've already done this unit. So here we have our first polygon. Here we have a polygon that is similar to it. And if a polygon is similar, that means its corresponding sides are proportional, which means that we've used the same scale factor. Let me just write that down. Same scale factor. But something else that we're going to also look at today is that the corresponding angles are equal. So let me show you what I mean by that. I'm going to label these shapes first. So I'm going to call this shape A, B, C, D, E, F. So at each vertex or each corner, I've given it a letter. So we would call this polygon A, B, C, D, E, F. It's a long name, but that's because it has so many sides. Our similar shape or our scale shape, we can also label. And we didn't talk about this yet, but when we're making a copy or a similar version of that shape, we can call it A prime, B prime, C prime, D prime, E prime, and F prime. So all I'm doing is adding little apostrophes to the letters to show that A and A prime are corresponding, but they're just on different shapes. So we would say that the corresponding sides would be side AB and side A prime B prime, side BC and B prime C prime, side DC and D prime C prime, and so on. So just like before, we have our corresponding sides, which are the matching sides, but we also have matching angles. So angle A would match or correspond with A prime. And the thing that we're adding now is that our corresponding angles are equal. So in this example, angle A was 90 degrees. A prime is also 90 degrees. So that's something to keep in mind as well. Our corresponding sides are going to have the same scale factor, and our corresponding angles are going to be the same. So let's take a look at a problem. Like I said, we can think of these similar shapes as scale diagrams, either enlargements or reductions. So we're really not changing anything. So here we have our original diagram. Here we have an enlargement. Are these rectangles similar? So for rectangles to be similar, first, the sides have to be proportional. So our sides are proportional, which means that we use the same scale factor. And we also have to have our corresponding angles equal. So already we can see our corresponding angles are equal because these are both rectangles, so all of the angles are 90 degrees. So our angles are already equal. The only thing that we need to check now is if the sides are proportional. So let's find some corresponding sides and then we can check that. So first thing, I'm going to use this side, so the long side in red, and that'll correspond with this side in red. So just like before, we can figure out what scale factor we used. And remember, scale factor is the scale diagram divided by the original diagram, the scale diagram length divided by the original diagram length. And in this case, our scale diagram was 15 centimeters. So 15 centimeters divided by our original, which was 4 centimeters. And that'll give us, excuse me while I bring out my calculator, 15 divided by 4 will give us a scale factor of 3.75. So our red sides, we used a scale factor of 3.75 to go from this 4 centimeter side to this 15 centimeter side. Now to double check that, let's check our other corresponding sides. So we have our blue corresponding sides. So again, our scale factor is the scale length, which would be this one here. So 11.25 centimeters divided by the original, which is this one over here, 3 centimeters. So 11.25 divided by 3 gives us a scale factor of 3.75. So we can say because both sides were enlarged with a scale factor of 3.75, both our red side and our blue side, we would say that this rectangle is actually indeed similar to our original. The angles are all equal, and the last thing to check off is that the sides are in proportion. So this was taken from our textbook. I'd just like to quickly mention it. So when two polygons are similar, so when two shapes are similar, their corresponding angles are equal, so the matching angles are equal, and their corresponding sides are proportional. So the corresponding or matching sides have been enlarged or reduced by the same scale factor. So if these polygons have these properties, the angles are equal and the sides are proportional, the polygons are similar. Or another way of saying that is that the polygons are scale diagrams of each other. So if we look at this example here, we have quadrilateral ABCD, which is this one here, ABCD. And this little squiggle mark here means that it is similar to quadrilateral PQRS. So when they tell us that they are similar, we can assume that angle A is the same as angle P, B is the same as Q, C is the same as R, and D is the same as S. And they've actually helped us with that. They've given us matching symbols in each angle that tell us that the angles are exactly the same. Something else that we need to think about are the corresponding sides. So side AB, let me do this in a color. Side AB, which corresponds with PQ, needs to be proportional to BC and QR. So I'm just going to color all of the corresponding pairs just so we can see them a little bit easier. SR and CD, and our last pair, PS and DA. So what we can start to do is we can start to look at the scale factor that we used to figure out all of these to get our enlargement. So our first pair, I'm going to do my red pair, the scale factor, and I'm going to put my scale diagram on top. So this one I'll put on top, so 2.1. 2.1 divided by 1.5, which gives me 1.4. Now I'm going to double check my blue pairs. So side BC and QR. So QR will go on top. So 4.2 over 3.0, which also gives me 1.4. So far, we're in proportion. Let's keep checking the rest of them. Now our yellow pairs. So RS and CD, RS will go on top. Scale factor equals 4.2 divided by 3.0, which is the same lengths that we just did, so that's also 1.4. And our last pair, we'll put SP over DA. So scale factor is 2.8 divided by 2.0. And guess what? We also get 1.4. So by doing all of those calculations, we've showed that we've used the exact same scale factor to enlarge all of our sides. So this shape here, our enlargement, is 1.4 times bigger than our original ABCD shape. Now what they've shown down here with all of these fractions equaling each other is what we just did. So this was the scale factor of AB and PQ. So let me write this out. And actually we did PQ. We started with this shape first. So we put PQ over AB. And that equaled 1.4. But what else equaled 1.4? Our blue sides. So we had QR over BC, which also equaled 1.4. So QR over BC. But that was also equal to RS and CD. So I'm setting up all of these fractions that actually equaled the exact same amount. And our very last one, our green sides, were SP divided by DA. So all of these fractions, PQ over AB, QR over BC, RS over CD, SP over DA, is exactly what we just did here. So our red fraction, we just calculated right here. Our blue fraction, we calculated here. Our yellow fraction was here. And our green fraction. So all of these fractions are all equal to each other because they all equaled 1.4. And when we set this up, this is called setting up a proportion or a ratio. So this set of sides was equal to this set of sides, was equal to this set of sides, which was equal to this set of sides. And that was how we can prove, if we go back up to where we were before, and it's not going to cooperate for me, but if we think back to what we needed, all of our sides had to be in proportion. And when we showed that all of these use the same scale factor, that's what we proved here with all of these fractions. And if that doesn't make sense, we'll do another example. So for this example, they've given us 3 rectangles, and they're asking us to identify which pairs are similar. So we're going to have to justify this answer. So right away we can see that all of these angles are 90 degrees in all of these shapes because they're rectangles. So right away we know that the corresponding angles are the same. But we don't know if the corresponding sides are in proportion. So we're going to have to do a little bit of math with this. So let's find 2 polygons. So I'm going to choose triangle ABC to start with, ABCD and EFGH. So we're going to compare this rectangle with this rectangle. So I'm going to label my corresponding sides. I'm going to have a blue side here and a blue side here. And I'll do a green side here and a green side here. So first for our blue sides, we'll do, and it doesn't really matter which rectangle we put on the top of the fraction and which we put on the bottom. as long as we make sure we keep it the same for both. So I'm going to call, just to make things easier, this rectangle number 1, this rectangle number 2, and this rectangle number 3. So just for our first comparison between rectangle 1 and 2, I'm going to keep rectangle 1 on the top of the fraction. So for our first blue corresponding sides, I'll do 8.5 divided by 8.4. So this side divided by this side. And we end up with, should be a number very close to 1. 1.01, and it goes on. Now let's compare our green sides. If we compare our green sides and we get the exact same answer as this, then we know they're in proportion. So let's find out. So just like before, I'm going to put rectangle number 1 on top. So 2.5 divided by 2.4. And oh, this might be very close. So this gives us 1.04 ... So those ones are not in proportion. If they are in proportion, we should get the exact same answers for both of these fractions. But we don't. So rectangle 1 and 2 are not in proportion. So they are not similar. So this was 1 and 2. Let's try out 2 and 3 now. So up here, let's keep these colors going. So now I'll color this side blue on number 3 and this side green on number 3. So for this time, we'll keep number 2 on top. So for our blue proportion, 8.4, which was the blue side on number 2, divided by the blue side on number 3, 5.25. And what does that give us? That gives us 1.6. Now let's do our green fraction. So keeping rectangle number 2 on top, we get 2.4 divided by 1.5. Let's find out what this is. 2.4 divided by 1.5. We end up with 1.6. So in this case, all of the angles are exactly the same in these two shapes, and we've used the same scale factor, or they're in proportion. So we used 1.6 to go from here to here, which means that rectangles number 2 and number 3 are in proportion. Let's check just for fun number 1 and 3. So this time let's put rectangle number 1 on the top of our fraction. So our blue sides will be 8.5 divided by 5.25. 8.5 divided by 5.25 gives us 1.62, and it goes on. Our green sides will be 2.5, running out of room, divided by 1.5, and that gives us 1.67 something. So those two numbers, or those two scales, are not the same. So we would say that numbers 1 and number 3 are not in proportion. So the only two rectangles that are proportional or similar would be rectangles 2 and 3. So unlike when we were dealing with scale factor, we're not too worried about which one is the original shape and which one is the scale diagram. As long as we're keeping the same shape on the top of the fractions and the same shape on the bottom of the fractions, we should end up working out. If you started to flip things around and not keeping track of that, that's when we end up with some answers that don't really make sense. But if you choose two shapes and keep the first one on top and the second one on the bottom, you should get the right answer. One more fun example. So this one, we have two octagonal garden plots, and they're telling us already that they're similar. So we know that we've used the same scale factor to either take this one and make it bigger, or to take this one and make it smaller. You can think about it both ways and it will work. The first thing they've asked us is to calculate the length of GH. And Where is GH? Here is side GH. So they are asking us to calculate this missing side. Now, if we look at what we have here, we have the corresponding side, and we know that the corresponding side on the larger diagram is 32.4. We also, if you notice this here, let me do this in, green will work. We have this little side up here, AB, and we also have the corresponding side, IJ. So if we have these corresponding sides, we can set up a proportion. Or, if you want to think about it, like calculating the scale factor. So what I'm going to do is I am going to pretend, for this example, when we're figuring out our blue side, that this is a reduction. So this is my original on the right, and I've reduced it to make the smaller shape on the left. So the first thing I want to do is calculate my scale factor. So this time I'm actually going to keep track of my scale factor formula. So my scale factor is my scale drawing, which is the reduction in this case, divided by the original. And in this case, we would have 5.4 divided by 8.1. Here's my scale diagram. Here's my original. So we end up with an answer of 5.4 divided by 8.1, 0.6 repeating, or 0.67. So now we can use that scale factor to figure out the size of the reduction. So all we're going to do is multiply the scale factor times the side that we know. So 32.4 times 0.6, because we're just going to take this side and make it 0.6 of what it was before, just like we did here. So 32.4 times 0.6 equals 19.44. So side GH is 19.44 meters. So that was pretty easy. The second part is to calculate the length of NP. So let me find a new color. Let's make this one red. NP is on this side here now. So we're going to try to find something on the bigger diagram. So for this question now, I'm actually going to, whoops, is that going to cooperate? Let me try this. I'm actually going to make this the original diagram. And I'm going to make this an enlargement. So this time, my scale factor is going to be the getting a little distracted here. My scale factor is going to be, that's what I wanted green. My scale factor, one more time, is going to be this scale drawing divided by this original drawing. So we're making an enlargement. So our scale factor is going to be bigger than 1. So 8.1 divided by 5.4. That gives us a scale factor of 1.5. So this diagram is 1.5 times bigger than this diagram. So our last step now, we can figure out our missing side because we have the corresponding side right here. And all we would do is take that 27 that we have, multiply it by 1.5 because we're trying to find out the bigger side on our scale drawing, times 27, and that'll give us a length of 40.5 meters. So in both of these examples, we treated our diagrams like our original and our scale, and then we had to flip it, so scale and original, because we want the side that we're looking for to be on our scale diagram. that just makes the math a little bit easier. If we're looking for a side on our original diagram, we have to work with a few more fractions and it gets a little bit messier, but it is still possible. So all we did was we labeled the side that we were looking for on our scale diagram, figured out the scale factor by using the corresponding sides that we know all the information for, and then multiplied the corresponding side that we were looking for to get our final answer. And I hope that makes sense. I've put lots of practice questions on Google Classroom, and there's also some textbook questions here on this slide here. Feel free to take a screenshot of that and get some practice done. Yeah, I hope that makes sense. If you have any issues, please feel free to ask me in class for clarification, and please do some practice problems.